I'm sure my likes and views will go through the roof because I'm doing you guys, right? 3 sides. Oh, you guys are too good. That was a tough one I started out with. Yep, triangle. 4. Be careful here because people usually say square. Rectangle. No, any 4-sided figure. What? Quadrilateral, yep. A rectangle is a type of quadrilateral. A square is a type of quadrilateral. Trapezoid's a type of quadrilateral, but any 4-sided figure. All right, let's go. Show off now. 5 sides. Pentagon. Up. 6. What do we? Hexagon. Seven. There's actually 2 names for it, and I've heard them already. Septagon, or somebody else said it. Heptagon. Septagon or heptagon. Yep, either one. Please do not say stop sign for the next one. Octagon. I'll put it in red for you. How about that? Oh, I love this. This is my favorite one. Nonagon. Na. 10. Wow, nice job, Lauren. Decagon. Anybody for 12? What do we got, Andrew? Dodecagon. Kids are unbelievable with your knowledge. How about 20? Anybody for 20? I have no idea either. It maybe have a name, I don't know, but once I get past dodecagon, whatever the number of sides is, ready for this? This is great. I call it a 20gon. Seriously, I call it a 20gon. You got 50 sides, a 50gon. Meaning n sides would be n-gon. I'm sure they have names. All right, I'm sure they have names, but I want you to be responsible for up to 12. All right. What happened to 11? I don't know. I think it's an unagon. Somebody may want to check that on me. I haven't done that in a while. Unagon. I would just go 11agon, but all right. Questions? All right, diagonal. You guys have been familiar with the diagonal, probably in a quadrilateral, but any type of polygon can have a diagonal. All right, so go ahead, draw yourself. I'll just draw my pentagon up here. Connects 2 non-consecutive vertices. Non-consecutive. So when you connect 2 non-consecutive vertices, you have yourself a diagonal. Well, what happens when I connect 2 consecutive vertices? It's called a side. Yes. Okay. So I could draw multiple diagonals in my pentagon here. All right, 2 types. Have you guys heard of these types before? Convex and concave polygons? Okay, regardless, convex polygon means every single diagonal is located inside your polygon. Okay, let me say that again. Every single diagonal inside the polygon. There are no diagonals outside. And some of you are thinking, well, how could they be outside? I'll show you in a second. All right, so convex, all my diagonals can be drawn inside the polygon. Do you think in your group right now you could come up with a polygon where at least one of the diagonals could be drawn outside? We call that concave. See what you can do in your group right now. See if you can draw one where a diagonal connecting 2 non-consecutive vertices could be drawn outside. See what you can come up with in your group. I don't want to give this one away. See what you can come up with. Try to come up with one where a diagonal can be drawn on the outside. See some decent ones here. Nice. I see some decent ones. And it could be any type of polygon. Nice, guys. Nice, nice. It doesn't look pretty. It's a polygon. 1, 2, 3, 4, 5, 6, 7 sides. And does everyone see the diagonal? I'll do it in dashed lines. Here's one diagonal I can draw on the outside. Here's another diagonal. So I would call this a concave. And a lot of people always think it caves in. All right. Somewhere on your polygon probably right now it's caving in. All right. So concave, there's at least one that can be drawn on the outside. Convex, they can all be drawn on the inside. All right. Let's get to the good stuff for today, which is the following. How many degrees in an octagon? I don't know. How many degrees in a 20gon? I don't know. You're about to find out a formula on your own now. Because you know how we roll in honors geometry. I don't give things away for free. All right. In your group right now, you're going to figure out what's the formula for the sum of all the interior angles of any polygon. Because you guys already know triangle 180, quadrilateral 360. Where does it go from there, though? Okay. So here's what I need you to do. I'm going to ask you guys for 1, 2, 3, 4, 5 figures. Triangle. Quadrilateral. Pentagon. Hexagon. Octagon. I'll go over the first 2, and then you guys do 3, 4, and 5 with me, okay? Number of sides in a triangle, we all know 3. Number of triangles formed, there's only 1. And what's the sum of the interior angles? 180, okay. Watch what I do here for quadrilateral now. How many sides in a quadrilateral? 4. Here's what I mean by number of sides, number of triangles. Let me get a quadrilateral up. From one vertice only, how many diagonals can I draw in here? From one vertice only. So I'm going to go from this vertice. How many diagonals can I draw in? Just 1, right? How many triangles are formed? 2. And you guys know how many degrees are in each triangle? 180, 180. Hey, guess where that 360 comes from? Because I can form 2 triangles. That's where that 360 comes from. Now I want you to do it for a pentagon. All right, I'll do the pentagon too, because I don't think the quadrilateral was a great example. All right, so Pentagon up right now, and you guys tell me how many triangles can be formed from one vertice only. So here's my Pentagon. Pick a vertice right now. How many diagonals can I draw in? Let's see, I can draw 1 right there, and I can draw 1 right there. How many triangles did I form? 3, each containing how many degrees? 180. So how many degrees are in the interior angles of a pentagon? 180 plus 180 plus 180, 540. You and your group right now, go ahead and do the hexagon and the octagon and see if you can find any pattern. So maybe if I gave you a bigger sided polygon, you could be able to tell me what the sum of the interior angles are. Okay, so go ahead with your group, finish hexagon and octagon, see if there's any relationship or any pattern. We know there's 6 sides in a hexagon. How many triangles were formed? How many? 4. How many total degrees in a hexagon then? 720. Octagon? 8. Number of triangles formed? 6. How many degrees? 1,080 degrees in an octagon. What are we showing here for a pattern? Let's go to that 20gon right now. I don't want to have to draw it. I know there's 20 sides. Prediction on how many triangles it'll form. So you're telling me it'll form how many triangles? Always 2 less than the number of sides. You're absolutely correct. And what are you doing with the number of triangles? You're multiplying it by 180 to find the degree measure. So in a 20gon, how many degrees? I don't have that one. Oh, can I get one voice here? 3,204. Wow, how about that? In a 20gon. So let's get a formula now. All right, let's get a formula. Polyangle sum theorem, all right, which says the following. The sum of the interior angles of a polygon equals. How'd you guys do it? How'd you figure out the number of degrees? You took what first? Number of sides and subtracted 2. So that's what I'm going to do right here. I'm going to say n, where n is the number of sides. I'm going to subtract 2 to it. And then what'd you guys do? You multiplied that number by? There you go. You found the formula all on your own. That's any sided polygon. That's how I can find what all the degree measures add up to. 180 times n minus 2. And n's the number of sides. In your group right now, numbers 1 and 2. Go. Numbers 1 and 2. 100 sides. Is he kidding me? Okay, here we go. Find the sum. And then find the missing angle below. So for this one, we should have 180 times 100 minus 2. 180 times 98. And that should end up being, what do we have here? 17,640 degrees in a hectagon. All right. All good? How'd you find the missing angle? Well, the first thing I needed to identify is what polygon is this? And this is a Pentagon. And if you do it or look back, most of you probably look back, the sum of the interior angles was what for a Pentagon? 540. All right, so my missing angle, I took 540 and subtracted the 4 angles that were given. 100, 117, 105, minus 115. And what'd you guys end up with? The missing angle? 103 degrees. Okay, not drawn the scale. So any issues with the interior? Because now we got to go outside. And yes, there's another pattern for the exterior angles of any polygon. Any questions about the interior? 180 times n minus 2. All right, let's go. I got to get moving. All right, what are we doing? Let's go. Do you want no homework or cut it in half? Okay. Okay, what's it going to be? What's it going to be? Okay, we're going no homework. What's the next slide going to be so we can get rolling? Fade? I got fade. I got slide. Fade? Or we got another? Fade. Okay, here we go. Promethean man or fade. First period only. Promethean man or fade. What? Are you recording? Yeah, I am. That's why I say first period only, because some person 8th period. Oh, we got no homework. Great. Right? Fade or Promethean man? Please no, please no. Whoa, who had the shatter? I heard the shatter. All right, going back. Let's go. Okay, let's go exterior now. I'm going to break you guys up in our usual groups of 3 I've had before. So group 1, group 2, group 3 over here. Here's what I want you to do on your specific polygon. Each group, please, at each interior angle, draw one exterior angle at each of your interior angles, please. So however many sides your polygon has, that's how many exterior angles you should have. And what I would like you to do is 2 things within your group. Find those exterior angles and add them up for me, because I want to know something about the sum of all the exterior angles. Okay? So at each interior angle, draw yourself an exterior angle, find those exterior angles, and add them up for me, because I want to find something out about the sum of them. And let's see if we find a pattern between the 3 groups. All right, somebody from group 1. What were your exterior angles? Go around for me, side. You're going to represent the group. Good luck, guys. 90. 95. 30. 85, and what did all 3 of them all 5 of them add up to? 360. Thank you. Group 2, need a representative here. Let me know your exterior angles. And what do all add up to? Group 3, representative. That's what I was thinking, 150, yep. What all of them add up to? Tough pattern here, huh? If I gave you a pentagon, never mind, a hexagon. Ha! If I gave you a hexagon and found all the sum of all the exterior, guess what it's going to add up to? It doesn't matter the polygon. It does not matter the polygon. The sum of all the exterior angles will always be equal to 360. Does not matter the polygon, guys. Does not. Interior, yes, we just figured out it does matter how many sides it has, but it does not matter how many sides it has for the sum of the exteriors. All right. Watch how many people I get here. Polygon's got 36 sides. Find the sum of the measures of the exterior angles. I got it. 27, how many? I didn't get them. 360. You change that 36 to whatever you want.
Someone's at 10 divided by 360.
Are you done?
What?
Am I missing something?
No.
Is everyone good on why it's 360? Because this is not then by far the toughest part of today. Yes.
Wait, does that mean all the sides are 10 degrees?
How can sides be measured in degrees, Nathan?
No, I mean the angles.
You mean every interior angle is 10 degrees? Not necessarily, and that's what I'm going to get into right now. Okay, it depends if, our big vocab word today, if the polygon is regular. Regular, that's huge. Here's what it means to be a regular polygon. 2 things. All sides are congruent. all angles are congruent. So in that previous example, going back to Nate's comment, if that 36-sided figure was regular, yes, they'd all be 10 degrees. The exterior angles, yes. Okay? So all sides congruent, all interior angles are congruent, and all the exterior angles are congruent. All right, ready to go? Now it gets fun. Yeah, here we go. Regular polygon. So all the sides and all the angles are congruent. It's got 20 sides. Find the degree measure of one, only one, not all 20. Find the degree measure of one exterior and one interior. Let's start with the exterior because I think that's easiest. What do all of them add up to on the exteriors? They all add up to 360. So I know all of them add up to 360. How many sides does this polygon have? 20, which means it's going to have 20 exterior angles. And because it's regular, all those exterior angles are congruent. So I can just take that and divide by 20. And I end up with 18 degrees for one exterior angle of that 20-sided figure. Everybody good? How do I figure out what all the interiors add up to? No, don't say it. Don't say it. How do I figure out what all the interiors add up to? What's my formula, Nate, you guys discovered? Okay, so here we go. One interior angle. I know some of you may have a different method. Shut it for now. All right, hold on to it. So I go 180 times 20 minus 2. So go ahead, find out how many degrees are in all the interior angles. In a 20-sided figure, we have what, 3,240? Yes, 3,240. And all 20 interior angles are congruent. So what should I be doing with the 3,240? Divide it by 20, and you end up with 162. Okay, let's talk here. I didn't need to do all this work to find the interior, did I? What is the relationship then between one interior angle and one exterior angle of any polygon? Think about what you guys, I'm not going backwards. I refuse to go backwards because I know it's going to be him. But look back in your notes if you want. What did you notice about an interior and exterior? They always added up to 180. They're supplementary. They're a linear pair. So once you find the exterior, I don't blame you if you did 180 minus 18 and got that 162 a little quicker. Fine. Okay, but if you still want to find the sum of the interiors and divide it by the number of sides, that's fine too. All right. All right, let's get a little crazy now. A little bit tougher with the problems as we lead to number 7. Find the number of, now you have to tell me the number of sides. Exterior angle is 120. One exterior is 120. It's regular, which means all the exteriors are the same. How many sides do I have? Whew, not too many voices now, huh? We'll take a look. Exterior angle. We know they all add up to what? What do all the exteriors add up to? 360, right? Each one's 120. I just got to figure out how many there are because that'll match the number of sides. What do you suggest I do with the 360 and the 120? Each exterior is 120, and I know they add to 360, so I should take the 360, divide by 120, and that'll tell me how many sides do I have. 3 sides, so this is a triangle. Everyone see how that worked there? Because we're going to get a little bit tougher in a second. We okay? All right, ready to go here. All right, I need you to dig deep for this one. Dig deep. Remember on this problem, I gave you the exterior angle. Now I'm going to tell you the interior angle. How many sides does it have if one interior angle measures 160? One interior angle measures 160 now. How many sides must it have? And I don't want you guys guessing checking. You know, I don't, let's say it's 8. Let's try 8. Let's try 9. Let's try 10. All right, we don't have time for that. See some different methods going on. Hey, everyone, let me ask you this question. How comfortable did you feel answering 5? Not 5 wasn't that bad, I hope. Make this into question 5 then. Interior is 160. What's the exterior have to be then? If the interior is 160, the exterior's got to be what? 20 degrees. You just turned this into problem 5. What do all the exteriors add up to? 360. And I know one of them is 20, so I can take that 360 divided by 20. How many sides? 18 sides. If at all possible, try to always deal with one exterior angle instead of one interior. Now, could you get away with doing this instead? 180 times n minus 2, which is what? The sum of the interior angles divided by the number of sides is equal to that one interior? Sure, go ahead. But I think you'd rather solve something like that, though. All right. Questions? Try to find 7 on your own in your group. We're going to finish it this way. I'm telling you the sum is 288. How many sides does it have? The sum of the interior angles of any polygon is 2,880. How many sides must it have then? No guess and checking. Ask yourself in your group right now, where did that 2,880 come from? Okay, let's finish this up. Again, the 2,880 is the sum of the measures of the interior angles. Do we have a formula for that? That formula you guys discovered at the beginning of class, which was 180 times n minus 2. Well, what's it equal to now? 2,880. How many of you guys distribute the 180 and solved? Okay, anybody divide by 180 and do it that way instead. You could divide by 180 right away. It's up to you, though, how you want to do it. Okay, so you can divide by 180 if you want. You can distribute it. I don't care. So that would give me 16 equals n minus 2. Add the 2 over. You guys should find out that this is 18 sides. Okay, 18 sides. Any questions from you guys? Okay, you guys owe me 6. I'm going to start adding on. I should probably stop this so people don't hear this.